So one thing I didn't realize, in between each vertebrae, this black area is called a vertebral disc, and it's actually a shock absorber. I was thinking of using silicone as my vertical discs, but I feel like that's too stiff when hardened. Although maybe some silicone dries softer than others, so it's possible certain types would be gelatinous enough to be a proper shock absorber. But I thought something even better would be like more of a gel. Something like this. My gel palm rest on my mouse pad, to me, would be the ideal consistency of a vertebral disc for my robot between each vertebrae. So I have to figure that out. I was thinking I could buy shoe insoles, like gel shoe insoles, and stack those as vertebral discs. But they need to be squishy enough that when the vertebrae are like this, and they come up and down in order to bend the back side to side or forward to back. And so whatever I put between my fists needs to be squishy enough to allow it to change directions. It's supposed to maintain contact with the entire knuckle face. So when I do this, it should expand, and when I do this, it should contract. It should be spongy. So these would be apart, and they just go like this, actually. What's up, Kranitz? So I've been thinking about what kind of gel I'd use as my vertebral discs. You can have a bulging disc, which means it's got like a bubble squeezing out in the human body, or a herniated disc, which I believe is when the disc is like fractured. I'm not sure, but I need to find some way to make an artificial disc. You know what? You're right. Some type of silicone, like silicone breasts, might be good, but that's maybe too squishy. It should be a little firmer than breasts. I mean, it is, after all, going to be under load. The load of the entire spine will be on these discs. You know, one of the great things about the human body is its shock absorption capabilities. If the robot were to jump and land, each of these black vertebral discs of the spine can compress because it's like gel. And so that prevents any cracking of the vertebrae. Plus, you can bend your back downward and squat your legs as you're landing, and that all absorbs impact as well. Machines are too rigid, like normally built with a solid frame. That's just asking for something to crack or bend or break. The way the human body is designed, it's all like very spongy and springy. If anything, something can maybe fracture in rare cases, but usually it's good to go. Let's see, maybe out of these holes actually comes branches coming off of the spinal cord. The spinal cord is what sends and receives information to muscles and from nerves. So I think spinal cords branch offs come through these little holes right here. The spinal cord runs through the back of the spine. The spine is like, it's like a solid bone with then a hole in front of it. The spinal cord runs through here, and then the solid bone is what touches the other solid bones for the actual structure of it. So the hole on the side is just for running your spinal cord. And then in front of that is then the little spiky thing that the muscles tie into of the spine. The muscles that run behind it and the back muscles tie into that. So there's a spiky thing, and then the two wings coming off the side. The wings are also for rotating it this way. Those are called the... Okay, so the spiky thing is called the spinous process, and then the wings are called... I don't know. I don't know what the wings are called. I can't remember. The viscoelastic disc prosthesis consists of 2 titanium end plates and an elastic core. Disc prosthesis. So that's this. He's referring to the discs in between the different vertebrae that form shock absorbers. So viscoelastic means it's viscous material and it's elastic, so it's stretchy. Viscous means like it's liquidy, I guess, or soft. So it's soft and elastic and it's a disc. Prosthesis means it's not real, it's man-made. So its prosthesis consists of 2 titanium end plates. Okay, so the titanium would be to prevent it from getting damaged on the tops and bottoms of the disc, and an elastic core. So the core is elastic, means it's flexible, which is firmly welded to the end plates. The elastic polymer, which means it's a subset of plastic, or it's a many material. It's usually polymer is usually referring to plastic, but it also means many materials are involved. So it's not very specific. Polymer could pretty much mean anything. The polymeric core allows free mobility. So it doesn't say in that sentence what that polymer is, and that's really what I'm trying to figure out. Should it be silicone? Should it be gel? Keyword there is viscoelastic. Yeah, I knew it needed to be elastic, and I knew it needed to be viscous. It needs to be like rubbery, but not too soft and not too hard. Silicone mold making material, like where you pour a silicone mold, seems to me like it would be a good material for the disc between the spine. But like construction silicone to me seems like it's just so hard when it's cured. It doesn't seem like it gives enough. Perhaps a good material actually would be foam. Polyethylene foam is an excellent shock absorber. It's used in, I believe, car bumpers. I'm not sure on that. I believe it's used inside those pillars on the road, although I'm not even sure on that. I'm not sure. All I know is it's used for shock absorption in an industrial fashion. It's definitely used for shock absorption in like helmets. I happen to have a supply of it because I sell polyethylene foam pillows. I know that it has great elasticity. I know that after you compress it, it always rises back out. I know that the absorption factor of it, thanks for the follow, Mr. Hodge. The absorption factor of it comes from air pockets trapped inside. So it'd almost be like air is what's creating the cushioning effect between the different vertebrae. So I actually think I figured it out. I think instead of going with a silicone or a rubber, which is also going to be a lot heavier, although there's only, 40 spinal discs, and they're only about this big each. So it's not going to be that heavy, but I mean, that could be an extra 3.5 pounds maybe. And I mean, 3 pounds is 3 pounds. That's kind of a lot of weight, especially when the key of the robot is to keep it as lightweight as possible because it's relatively weak. I just feel like polyethylene foam would be ideal because it's lighter in weight. I feel like it would work, guys. I would try polyethylene foam first and then go with more of a solid rubber after that. I feel like polyethylene foam would be superior. Foam will wear out, especially under load. Well, you could always replace it pretty easily. I would basically open up the back. I would cut my stitches that connect the vertebrae together through my elastic setup, which is basically my spandex material, which I use as artificial ligaments. Or, yeah, ligaments. And then I'd be able to open up that spine, that pair of vertebrae, slide out the somewhat worn out polyethylene, and slide in the new. But foams wear out different foams wear out at different speeds. From my experience, polyethylene seems to last pretty long. It does have pretty good, like when you compress it and then let it go, it does grow back out for a pretty long time. So I don't know. I think it would be like spinal surgery actually. Every time I go to repair my robot, since it's so closely based on human anatomy, it is going to be very similar to surgery in many ways. It's going to be funny. So I never went to medical school, but in a way I'm still going to get to be a surgeon. Oh my gosh. See, but that would wreck my stuff because I'm going to have fiberglass vertebrae, and these spikes and stuff would really break my vertebrae of my robot. So I couldn't use something like that. My solution has to be a lot more tender. They're going for long-term zero maintenance and maximum strength for a human body installation. Number one, my robot won't be as heavy as a human body. Number two, its bones won't be as strong and dense. So any type of spikes pushing into them would crush them pretty much.